It's a little difficult to put the definition of a square root symbol into words, but here's an attempt to do so. The square root symbol just means find me a number that when multiplied by itself gives me the number under this sign. And it's important to remember that the square root symbol by definition is asking for the positive square root. So for instance, the square root of 4 is 2 because 2 times 2 is 4. However, it's not negative 2 because again, by definition, the square root symbol is asking for the positive square root. Here's a problem. Give it a shot. If a squared equals 9 and b equals the square root of 16, which of the following could be the value of a plus b? And we're going to select all that apply here. All right, well, let's start with the first statement. A squared equals 9. What number, when you square it, gives us positive 9? Well, certainly 3, right? 3 squared equals 9. But so does negative 3. If I square negative 3, then that equals positive 9. So that means that a could equal 3, but it could also equal negative 3. All right, let's go to the second one here. B is equal to the square root of 16. So you might be tempted to say, well, 4 or negative 4, right? But remember that by definition, the square root symbol is asking for the positive square root. So the square root of 16 is just 4. So with that said, we can answer this question now. A could equal 3 or negative 3. B is equal exclusively to 4. What's the value of a plus b? Well, it could be 3 plus 4, 7. It could also be negative 3 plus 4, which is 1. So 1 and 7 are the answers to this question. The sign of a number, that is, whether it's positive or negative, can have a huge impact on the outcome of a problem and potentially change the answer. So we have to keep very, very close tabs on whether numbers are positive or negative and what happens to positive and negative numbers when we start using exponents. So here are 2 rules to remember. If I have a number and I raise it to an even power, automatically it becomes positive. It doesn't matter if that number was positive or negative to begin with. If I raise it to an even power, it becomes positive. And if I raise a number to an odd power, well, it just retains its sign. It stays positive or negative. Here's an example of what I'm talking about. If I take the number negative 2 and I raise it to an even power, like 2, so in the top line there I have negative 2 to the power of 2, that's going to equal a positive number. Negative 2 times negative 2 is positive 4. And on the second line there, if I take that number, negative 2, and I raise it to an odd power, well, then it's going to be negative 2 times negative 2 times negative 2. The outcome is going to stay negative. So again, just the rule to remember. If I raise a number to an even power, it becomes positive. And if I raise a number to an odd power, it keeps its sign. So we're going to take a look at a new type of question here, a quantitative comparison question. These ones might seem pretty daunting, but the assignment is actually pretty straightforward. And here's how it works. You're going to get a piece of information. So under example there, it says x squared y is less than 0 and x plus y is greater than 0. That's some information that the problem is giving you. And then it's just asking, what is greater, quantity A or quantity B? It's a comparison. So if quantity A is greater, you're going to choose A. If quantity B is greater, the answer is B. If the two quantities are always equal, then the answer is C. And if it's impossible to determine the relationship, sometimes A is greater, sometimes B is greater, then you're going to choose D. Let's give this quantitative comparison thing a shot. So the idea here again is I'm given this piece of information at the very beginning. X squared times y is less than 0 and x plus y is greater than 0. Well, if I know that x squared times y is less than 0, another way of saying that is that x squared times y is negative. And let's think about the implications of that. So this number times this other number created a negative number. What does that tell me about these numbers? Well, it means that one of them is positive and one of them is negative. Because if I multiply a positive times a positive, that's going to give me a positive. And if I multiply a negative times a negative, that's going to give me a negative, positive, also a positive. There we go. And the only way to get a negative is to multiply a positive times a negative. So one of these must be positive and one of them must be negative. Well, how do I know which one is which? Well, this is x squared, right? And anything squared is going to be positive, as we saw. So if this one is positive, that means that y must be negative. So what I can draw from this first statement here is that y is negative. I'm going to put a little negative symbol next to y to keep track. Okay, well, let's go to this second one right here. X plus y is greater than 0. X plus y is greater than 0. So another way to say that, of course, is that x plus y is positive. Well, I already know that y is a negative number, right? Y is a negative number. And if I add something to y, and that made it positive, that thing that I added must be positive, right? Because if I added a negative number to y, it would have stayed negative. In this case, I added a positive number, and that made it positive. So now I know that x is positive. And the goal here is not to figure out what x and y equal, it's to figure out which one is greater. A positive number is greater than a negative number, so quantity A is greater in this case. The GRE doesn't often test your knowledge of odds and evens, but the topic does come up, so let's quickly run through the rules here. If I add an odd and an odd, I get an even. If I add an odd and an even, I get an odd. If I add an even and an even, I get an even. If I multiply an odd by an odd, I get an odd. If I multiply an odd by an even, I get an even. And if I multiply an even by an even, I get an even. Now, you might be saying to yourself, do I need to memorize all of these? And the answer is no, because there are no exceptions to these rules. So if you want to know what an odd plus an odd is, just pick two odd numbers, add them together, and see what you get. And that will always be true. So with that said, let's give this problem a shot. If j is an even integer and k is an odd integer, which of the following must be odd? There's that word again. Must. Has to be true, no exceptions. So if we can find an exception, then we can eliminate that answer option. All right, so right off the bat, we can get rid of d and e, and here's why. Whatever j and k are, right, or whatever this sum or difference ends up being, we're multiplying it by 2. 2 is an even number, and if I multiply an even number by anything, whether it's even or odd, then that's going to create an even number. And I'm looking for an odd number. So those are out. And let's run through the remaining ones here. J plus 2k. Well, I know that j is even, so this is going to be an even plus 2 times an odd. An even times an odd, which is even. So even plus even creates an even. A is out. 3j minus 4k. 3 times an even number is still even, minus 4 times an odd number. That's even. And subtraction works the same way as addition. An even minus an even is still even. So the answer has to be C. And just to prove it, let's plug in these numbers, right? J is an even number. An even number times itself 3 times, even times even times even, is an even number. Plus 3 times an odd number. An odd number times an odd number is an odd number. Even plus odd, that's an odd. So the answer is C.